Alright, 6.3 similar polygons. Objective. Students will be able to identify similar figures and solve problems involving scale factor. So before we get started on this video, I want you to recall, why could we not prove triangles congruent using AAA? Why did that not work? Well, if you remember, we said that if three triangles had, all the same angles, they could still have, oops, my drawing's horrible there. They still could have different sizes. So here, these two triangles have all the same angles. These are both right angles. These both have two little arcs marked, and these have three arcs, so they're all the same angles, but they're obviously different sizes. Well, that was similar. Those are similar triangles. We didn't know it then, but now we can see that those were similar triangles. So what happens if we only have two angles? Is that enough information to say the triangles are similar? It should be, for a couple different reasons. For one, we learned a while ago that if we had two triangles, let me draw a little bit nicer one, and we said, hey, you know what, these two angles are congruent, and you know what else, these two angles are congruent. We said that should be enough information to say that the third angles are congruent using the third angle theorem. So the same should be true here. All the angles would be congruent, but let's test it. And this is just something you guys could do on your own. And get out a ruler and measure in millimeters or centimeters, but probably millimeters, all these sides. And you could put them all here on the top. Then you can measure all of these sides with your ruler, put those measurements on the bottom. And then you should get a ratio that is really, really close. The only reason why they won't be exact is because of human error, but go ahead and try it. See what you get there. Plug in some values. I will try and do it as well and show you what I got. So go ahead and pause the video now and just try and measure those on your own. Okay, so when I measured, I got 9, 32, and 33.5 millimeters, and here I got 17, 58, and 60 millimeters. Now granted, my measurements could be a little bit off because of human error, but when I plug in my ratios, I get 32 over 58, 9 over 17, and 33.5 over 60. If you were to plug these into your calculators, you'd get numbers that are really close. They won't be exact because, again, human error in measuring, but they are close enough to show that, yes, in fact, these two triangles are similar. And what did we start with? Well, we started with D being congruent to R and E being congruent to S. Well, with only two angles, we were able to find that the triangles were indeed similar. So that's enough to say that with just two angles, the triangles are similar. So this postulate 6.1 is shown. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. That's what we just kind of demonstrated with that little bit of math. So for example, since D is congruent to R and E is congruent to S, that's enough information to say the triangle DEF is similar to triangle RST. And so that means that we can also go to theorem 6.1 here, and that's side similarity. What that means now is if we have all three sides of both triangles being proportional, so if the measures of the three of the corresponding sides that's an N right there, of two triangles are definitely proportional. Remember, that means that all the scale factors are the same. If they're proportional, then the triangles are similar. So for example, we did the ratios. We found out they were all the same. So that's enough to say that triangle DEF is similar to triangle RST. And then we have another theorem, that's SAS similarity. And that one says that if the measures of two sides of a triangle are proportional, to the measure of two corresponding sides, I'm just going to write CORR, but that stands for corresponding, corresponding sides of another triangle, and the included angle or the angle in between are congruent, then the triangles are similar. That's all we need to prove that they're similar. So DE over RS is equal to DF over RT, so we have proportional sides, and the angles in between are congruent. Therefore, triangle DEF from the page before is similar to triangle RST. Okay, so here's an example problem, and we're going to work this one out to see if we can show that these two triangles are similar. The first thing that I want to do is I want to mark the given information. So they told me that FG is congruent to EG, but what all does that mean? Doesn't that also mean that these angles across inside this little triangle are congruent? So I'm going to mark that. Okay, now let's apply some of the other information here. We know that BE is 15 and CF is 20. And those are parts of different triangles. And then AE is part of this triangle and DF is a part of this triangle. What I'm going to do is I'm going to try and color code this. So I'm going to do the triangle on the left in red. So BE, well that's this distance here. BE they told me was 15. And AE is this distance down here. Told me that was 9. Now let's do CF. CF they say is 20, so let's do that side in blue. And then DF is this side here, that's 12. So the whole point of all this, I know it's looking messy, is that we said if two sides are proportional and the angles in between are congruent, then the triangles are similar. So we're trying to determine if these triangles are similar. Well, if you look at it like this, here's the red triangle. We have a side and a side. They gave us 15 and 9, and we got to find out if it's proportional with 20 and 12, which I'm pretty sure it will be. And we have that angle in between and that angle in between 20 and 12. So we do have an angle between two sides and an angle between two sides. So as long as these sides are proportional, then the triangles are similar by SAS similarity. So we need to see, is 20 over 15 the same thing as 12 over 9. And why did I set this up this way? Well, 20 is from the big triangle, and it looks like the corresponding side would be 15 in the smaller triangle. So I did 20 over 15. Since I did the bigger on top, I'm going to do the bigger on top over here, and I did 12 from the big triangle over 9. Well, is this true? What's 20 divided by 15? Well, I could take a 5 out of both of those, and I end up with 4/3. And 12 over 9, I could take a 3 out of both of those and end up with 4/3. So yeah, they are proportional, and we have the angles in between, so we could say yes by SAS similarity. And obviously this is different than side angle side congruence, right? Because this is to show that they are similar, not necessarily that they're congruent. All right, let's take a look at this one. Now it says find AE and DE. I'm looking at something specific here. I notice these little arrows. Those arrows don't mean congruent, right? They mean parallel. So that tells me that this angle here is going to be congruent to that angle there. And I also know that this angle here is going to be congruent to that angle there. Those are both by alternate interior angles. And then lastly, I'm going to mark this like so. We have vertical angles. So we have three angles the same. Therefore, yes, they are definitely similar triangles. So now we just need to set up the ratios. It looks like the corresponding sides here is x minus 1 to x plus 5, and then 2 to 5. So I'm just going to say, hey, x minus 1 corresponds to x plus 5. So this time I did the smaller triangle over the bigger triangle. Set that equal to 2 over 5. So cross multiply, I get 2x plus 10 equals 5x minus 5. And let's just do a little solving. So we get 15 equals 3x, and therefore x equals 5. Okay, but that's not what they wanted, right? They wanted AE and DE. That's not that big a deal. Let's just plug it in. So AE equals 5 minus 1, which is 4. And DE equals 5 plus 5, which is 10. Boom, done. So summary, how would you define similar in your own words? Also, think of at least one application in the real world. So think of something that's similar in real life. It may not be a two-dimensional shape. It could be a figure, it could be a thing. But think about how you would define similar and use a real-world example.